Nav4you, a startup spin-off of the Geoloc laboratory in France, initiated CHARLI project in order to secure and optimize first responders' interventions. The company uses innovative algorithms merging inertial, magnetic, and GNSS data to determine the user's position with a foot-mounted device. Our algorithms include an artificial intelligence model allowing to detect a wide variety of human movements. We are also able to use GNSS measurements even degraded and indoors to correct velocity estimation. Here is the architecture of the complete solution. The agents in intervention are equipped with a foot-mounted location device, a computing unit, and possibly with a user application that is not mandatory but offers more features in some scenarios. The data is transmitted to a communication gateway near the unit manager, allowing him to follow the trajectory of each agent through a supervision software offering a wide range of services. The data is also stored in a server to perform post-intervention analysis and optimize deployments. Phases 2 and 3 of the challenge allowed us to develop a first prototype of the foot-mounted device that integrates the different sensors necessary to our algorithms. For Phase 4, we developed a new version of the remote calculator with a smaller form factor, sufficient processing power for quick prototyping of new algorithms, reduced power consumption for battery and thermal considerations, and the integration of a LoRa communication system. We added LoRa technology to our solution to enable information transmission to a gateway at the command center even when there is no cellular network available. During this phase, we worked to improve the software aspect of our solution, incorporating feedback from professionals. We added several new features, including user direction to guide agents towards specific locations, an uncertainty ellipse to assess the reliability of the location estimate, and the ability to refocus the map on an agent's position or to enable or disable the display of the full trajectory for better visibility. We also added a new tab dedicated to the Z component, which includes elevation variation and an estimation of the agent's current floor level. Finally, in emergency response situations, knowing the exact location of first responders is crucial, but without the proper context, that information can be limited. That's why we developed a powerful feature that allows users to add an evacuation plan to the map background. By simply taking a picture of the evacuation plan, cropping it, rotating it, and selecting the position of 3 common points, users can seamlessly integrate it into the map background as a transparent layer. During Phase 4 testing, we confirmed the decisions made based on feedback from the first responders. They appreciated the stand-mounted design with a smaller size in the future due to its ease of installation. The application received positive for its intuitive interface. In a practical test at the hospital, an agent was able to locate a colleague equipped with the device in approximately 1 minute, a task that would typically take significantly longer. In Phase 5, we significantly advanced our hardware development. We finalized the design of our foot-mounted tracker, utilizing materials tailored for extreme temperature resistance and immersion. The updated unit incorporates additional sensors and a novel electronic board, enhancing our algorithmic capabilities. Remarkably, this version is 80% smaller than the previous model. The displayed device is a preliminary 3D print, exemplifying the reduction in size. The official devices are set to arrive in early October. For commercial purposes, we have designed a dedicated charging base that can hold up to 5 devices. A single device variant is also offered. The latest iteration of our computing unit has been finalized, featuring enhanced durability, water resistance, and a new attachment mechanism. As a new feature, it includes 2 prominent push buttons that can be pre-configured prior to a mission. These buttons enable geolocated functionalities, such as marking an exit or indicating the location of an individual requiring rescue. This data is directly relayed to the unit supervisor through the application. Another major step developed for this phase is multi-agent management. The communication infrastructure has been revamped, enabling the application to concurrently display up to 5 users. Every user is now uniquely identified by a specific color for rapid recognition. The display for floor changes remains accessible for all agents. We've also added the GPS position of the communications gateway, located at the Operation Control Center, using a truck icon. We've implemented several algorithmic enhancements, notably introducing a carrier-neutral calibration stage.